Now, the first page of this review was out of 18. This back page will be worth 2 marks each as well. I'm feeling blue today, but not sad blue, just feeling like the color blue. Plus 12 cubed 4, which is 20 cubed 4. Now, often when I am giving tests on radicals, my students see a 4 under a radical sign and automatically start bringing out 2. Of course, you can't do that because of the index. Pay attention to what is happening. That is, of course, also why I use 27, 8, and 64, because I was searching for cube roots, not square roots. Number 15, I like that question because if I walked around, I would see a bunch of my students that wrote root 6 over root 6 and proceeded to rationalize that denominator. There is, of course, no need to do that because the answer is root 7. But on Friday, when I was listening to people, or Thursday, or whenever the heck we were doing this, a bunch of people were rationalizing that denominator. It's extra steps. You're going to get to the same answer anyway, but why take extra steps? This one, of course, you will need to do some simplification, but 24 doesn't divide by 18, 4 doesn't divide by 3, 3 doesn't divide by 4, so of course you would simplify. That is 4 times 6, that is 9 times 2, which gets you 6 root 6 over 12 root 2, which does divide nicely into root 3 over 2. Now, a lot of my students tend to have issues with understanding how this becomes this. 6 over 12 is 1/2. Root 6 over root 2 is root 3. Root 3 is technically root 3 over 1. That is why you end up with root 3 over 2. Yeah? Yeah. This one, again, I would simplify, of course. That is 120 root 2 over 10 root 5, which is 12 root 2 over root 5, which, of course, you rationalize to get 12 root 10 over 5. And that's where you stop. I am no longer feeling blue. I am now feeling whatever color that is. Pink. That's not pink. Horse crap. Apparently it is. You've seen this one before. What does this really mean? Cube root of 8k over the cubed root of 3. Now, of course, you would simplify that. That is 2 cube root k over cube root of 3. Now, again, you have to know what you're actually doing. You can't just memorize steps. Because if you memorize steps, you're going to multiply this by cube root of 3 over cube root of 3. That is not going to do what you are trying to do. You are trying to get rid of this radical sign, which means you must have something cubed under there to take it out. So you must multiply by 3 squared. Now, of course, because you know your exponent laws, you have 2 cube root 9k over 3. Because 3 times 3 squared is 3 times 9, which is 27. And the cubed root of 27 is 3. Now I'm okay. And of course I can do no more because 2 and 3 does not get any simpler. Yeah? Remember, What if I had, and you don't need to write this down, the fourth root of 5? What would I have to multiply by to get rid of that? Fourth root of 5 cubed. What if I had the sixth root of 7? What would I have to multiply by? Sixth root of 7 to the fifth. What if I had the sixth root of 7 to the fourth? What would I have to multiply by? Sixth root of 7 squared. Everybody good? Remember, I cannot teach you this for every single number because numbers go on till infinity. Right? Back over to here, I must multiply by 5 root 3 plus root 2. What do we call that expression? A conjugate. I should have changed colors because it's getting busy here. That is 35 root 3 plus 7 root 2 over. Can I just do this in my head, or do people need to see it? Okay, it's 75 minus 4, which is 71. Then you simplify anywhere you can. There is nowhere to simplify, so you're done. Everybody knows why that's 71, right? 73. Oh, yeah, it's 73. And then this one, I will change color again to keep it less busy. That is root 2 minus 2 root 5 over root 2 minus 2 root 5, which gets me 3 root 2 minus 6 root 5 plus 4 root 2 root 6 minus 4 root 15 over 2 minus 4 times 5 is 22 minus 20, negative 18. And there is nowhere up there to tidy up. 3 root 2, 6 root 5, 2 root 6, 4 root 5, 15. Yep. And then, without a calculator, of course, what do? You make them entire radicals. If there's 1 5 out there, that means there were 2 under there. So that is the root of 125. That is the root of 16 times 7 is 70, and 42 is 112. That is 140 minus 14, root 126. And that is 4 times 30, root 120. Then you put them in order from least to greatest. So it is 4 root 7, 2 root 30, 5 root 5, and 3 root 14. Everything on that page is 2, 2, 4, 6, 8, 10, 12, 14, 16, 18 marks and 18 marks for a total of 36 marks. When will you report that number to me? Tomorrow on your test. You will write your name, and then you will write a number out of 36. Some of you will forget that number out of 36. You will see your check my mark score after I mark your test. You go, ah! And then I will say, that is because you did not tell me what you got on your review. Yeah? You didn't. You're joking, right? Okay. I'll give you that. I don't like it, but I'll allow it. Rhea. Question 21. Well, you're giving him a hard time. He keeps a tidy beard.
No, I FaceTimed him at like 12 when it was his birthday. Just happy birthday.
Oh, I see. You give yourself an appropriate amount of marks there, David.
Oh, you put beard, that's what I
Well, that depends. If you forget, like you forgot that negative. If you were to forget like that negative, 22 minus 20, I don't care too much about that. But if you do something up here wrong, like you did that by plus, huh? Oh, then I would maybe take away a half mark. Are we all good? All right. So, I did promise you test reminders as study. So these are one. You can simplify radicals with numbers and variables. So you should be able to simplify something that looks like this. Everybody knows how? No, it's 81. That is, of course, 3 to the 4th, x to the 5th, y to the 7th, which is, of course, if it's 3 to the 4th, out comes a 3, out comes an x, out comes a y, and I left a 3 under there, 2 x's, out comes 2 y's, and 1 y. Everyone should be able to do that for their test tomorrow. You don't necessarily need to be able to do it in your head, but you should be able to figure it out. Yeah? Yeah. Point number 2. Everyone should be able to add like radicals, which means you all should be able to do 6 root 2 plus 4 root 2 to get what? 10 root 2. It also means you should be able to simplify to make like radicals. So if you had something like this, cubed root 16 plus 5 cube root 128 minus 3 cube root 54. You should be able to tidy that up to do your adding and or subtracting. Of course, that is just taking step 1 and moving it in here. That is, of course, 8 times 2. That is, of course, 64 times 2. And that is, of course, 27 times 2, which gives you 2 cube root 2 plus 20 cube root 2 minus 9 cube root 2 to give you an answer of 13. 22 minus 9. 13 cube root 2. Yeah? Yeah. The third thing you should be able to do is multiply like and unlike radicals. If they're like radicals, what do they have? What? Yeah, they have the same index. If they are unlike radicals, they have different index. So, you all should be able to do 3 root 7 times 2 root 5. What does that give you? 6 root 35. You also should be able to do 3 cube root 4 times 2 root 5. What does that give you? Six cube root 4 square root 5, because it is the exact same as 6x. Sorry, it is the exact same as 3x times 2y, giving you 6xy. You just line them up. Okay? What is the trick to remember here? Simplify as often as you can. So if you are faced with the root of 128 times the root of 588, you would of course not multiply those. You would simplify first. Right? Okay. And the fourth thing, you must be able to divide and rationalize. So divide is easy. 6 root 12 over 3 root 4 is 2 root 3. How do you remember it? It's coefficients divided by coefficients. Then arguments divided by arguments. And you follow fraction rules. However, 6 root 12 divided by 3 root 5 gets me 2 root 12 over root 5, and that, of course, is not allowed. And we must rationalize. Yo.
First question, isn't the root of 4 2?
Yeah, but then it would be 6. Wait a minute. So that would be 6 root 12 over 6. The 6's would cancel. You'd have root 12, which is 4 times 3, which is 2 root 3. Rationalize right there. And remember, conjugates. That's everything on one page. Your test is on this tomorrow. You should all be ready to go. The only thing that was new was rationalizing denominators. And rationalizing denominators is multiplication, which we already learned in grade 10 and was reviewed for you in grade 11. Yeah? The only time it gets tricky is conjugates, and the only reason that is tricky is because too often students are too lazy to write it all out. If you write it all out, it's really, really hard to do it wrong. Everyone is good? All right. Now, you will notice the next unit is polynomials. If you turn your page, you will notice that I have not deleted last semester's. You will notice that we are beginning with polynomial multiplication. No need to stress about that because you already know how to do it. It puts together conjugates and exponents. You don't need me until like the third page. So, let us begin with page 50. And page 50 should take about 3-4 minutes. There are all kinds of tricks to multiplying polynomials. I would suggest you make sure you remember how to multiply them the long way before you start jiggering around with tricks. But that's just me. Of course, that song was ripped off from the 1983 song by the Canadian pop artist Luba. Let's choose a color. These colors all bore me. Those colors all bore me.
Silly goose, the x's cancel out, the middle cancels out, x times x squared.
Ooh, lavender. Light blue. Where was lavender?
No.
I think I already have lavender.
Yeah, it's x minus x before you, so yeah, remember 20?
Oh, man alive. Let's go, people.
Same thing. 9y squared minus 144.
Is everybody done yet?
No.
There is up to J. Make sure you remember how to do all of this. I've been doing a bit of math. What? That should be 15. That should be positive. 3x squared. Okay. No, that should be a 13. That's one of those disappearing strokes of ink. That happens on this computer because it's so high quality. Everyone is good?
Oh, so the trick doesn't work up until...
That little trick only works when the variable has no coefficient. All right. We should all be good on that, yeah? Like, especially after our unit on rationalizing the denominator. Everybody should be good with this, yes? It doesn't matter if you can't do it quickly. As you can see, when I did mine like 10 times as fast as you guys, I made 3 little mistakes. Fortunately, I have you people, all 30 of you, to make sure that I don't get a swelled head. All right? All right. That is, of course, the basis of this unit. Now, turn the page over, and we remind ourselves that factoring is the reverse of multiplication. So, in multiplication, we have 2 factors, x plus 3, x minus 7. They are factors because this binomial is multiplying by this binomial. That gives me, that is a factor 1, that is factor 2, and it gives me a product. And the product is x squared minus 4x minus 21. Factoring goes the other way. It takes a product and breaks it down into factors. There are 3 types that you already know from the 10th grade. First type is Gcf factoring. This is what you should always try first. Always, always, always try this first. And it works the same way. Step 1. Decide on the GCF of all terms. Step 2, divide all terms by the GCF. And step 3, write your answer in this form. GCF bracket, then all of your quotients, plus or minus quotient 2, and so on. Most of these you can see in your head, but sometimes you can't. So this one, there is term 1, there is term 2. What is the GCF of both terms? 3. So the GCF equals 3. So step 1 is we decided on the GCF. Step 2, divide everything by 3. Step 3, write it as GCF, bracket, first quotient, 2x, plus second quotient, 1. That's how you do it. You all remember how to do it. You all know how to do it. And you saw me do that a few times in the radicals unit. And I said, if you didn't remember that, it was okay. But now you've been reminded. So is it going to be okay? No. What's the GCF over here? 2x. So I divide them both by 2x. Rewrite 2x plus 3. Right? Excellent. What if I gave you this? What's my GCF? 3xy. Why is it only one x, only one y, and no z's? Z is only there, so it's not common. 1y, 2, 3, but only 1 is common to all of them. X, 1x, 1x, 2x's, only 1x is common. So I then divide everything by 3xy, and I rewrite 3xy. What's the first one going to be? 5x y squared plus 6y minus 9z. Okay? Everybody can GCF, right?
Yes.
Okay, I want to mess with your heads. Do not write this down, just look. What's the GCF? X plus 4. Because it is in all of them. So how would I factor this? I know the GCF is x plus 4, so what do I do? He waited patiently. I would divide everything by the GCF, just like I've been doing all the way along. Then I would write the GCF first, and then all my answers. 3 plus what?
7.
Minus what?
8.
To get 2. 2x plus 4. Which, of course, you could do just by adding it up, because you can see they are like terms. Aight? Aight. Do I need to talk about GCFs? No. Good. Now, trinomial factoring. Because you were in the 11th grade and you've already seen this to death in the 10th grade, I would like to avoid showing you why this works and just showing you what to do. Is this all right?
Yes.
Excellent. When you see a trinomial that has no number out in front, it's got no leading coefficient, then this is what you do. You are seeking two numbers. And those two numbers have to do two things. One, they must add to the middle term. That middle term has a special name. It's the linear term. You don't really need to know that right now, but I'm going to be referring to it in later units. And the other thing they must do is multiply to the constant. So in this case, they must add to -8 and multiply to +7. What are they? -7 and -1. So the answer is x minus 7 and x minus 1. Just to remind you of this, let's do a couple more. Do the blue one and the green one on your own. Well, I stretch. What's the blue one? X plus 3, x plus 4. What's the green one? X minus 15, x plus 2. Good, I didn't fool anybody. People saying it's 10 and 3. Everybody good? What if I mess with your heads? No, I'll do that in a minute. Come over to here. What's different? There's a leading coefficient. So what should I try first? This bugs me. So I try to get rid of it. How would I get rid of times 3? I would divide everything by 3. Does it work in this case? Yes, I get x squared plus 6x minus 8. So now I only have to factor that. And to factor that, I need numbers that multiply to what?
8.
Multiply to -8 and add to 6. Are there numbers that do that? Four and 2 will add to 6. 4 and 2 to multiply to -8. One of them would have to be what?
Negative.
One of them would have to be a negative, which means they would not add to 6, would they? So I can't go further. What if I change this to +8? Now could I do it?
Yes.
And what would it be? 4 and 2. So then it's 3x plus 4, x plus 2. Is everybody good? Now, every question you face with these terms will always follow these rules. The only thing that happens is a couple of things get added to them. Do not write this down. Just pay attention. You could all do this in your sleep. Right? Right? You've all got the answer in your head right now, yes? Everyone does? And of course you all have x plus 2, x plus 3, correct? If I gave you x squared minus 10x plus 24, you could do that. Because that would be x minus 6, x minus 4. Right? For some reason, if I make this question this, my students say they can no longer do it. You are none of those students that would say they can't do that, right? What is this answer? Yep. Everybody with me? It's the same thing you know. You just have to accommodate for something new. But it's the same principles. Do not hand me that line that kids like to hand me. How I can't do it and it looks that way. That's like saying my projector is busted, so I had to do the math on the whiteboard, and you'd all be like, that's different. I can't do it. Right? Good. And now the third way. Well, it's actually 2A. If I write that, could you factor it? Yep. You need numbers that multiply to what? -9 and add to what? What are they? Yep. X plus 3, x minus 3. What if I gave you this one? What would that be? I would need to multiply to -36, add to 0, and I would get x plus 6, x minus 6. Yes? Okay. What is wrong with the way I've written the two blue trinomials? Those should not be there, should they? So the two blue trinomials should really be x squared minus 9 and x squared minus 36, yes? Difference of squares. Squared minus squared. Squared minus squared. What is the answer? Always the square root of that, twice. It's the conjugate rule that you've already learned, yes? So, what if I gave you this? 4x squared minus 25y squared. Yep. What's the root of the first one? 2x. What's the root of the second one? Plus 5y. And then we just write it again. What if I gave you this one? What would you do with that? Of course you would GCF. What is the GCF there? 2, which would give you 4x squared minus 25y squared, which you know how to factor. Right? What if I gave you this? What are you going to do with that one? I know you know. You learned how to factor these in grade 4. Was it grade 4? When did you learn how to do these? What grade? Grade 6. Grade 6, you guys were still reminding yourselves how to add fractions. Grade 6 over there, they're factoring polynomials. No. If you want to take forever to do a question that will take 2 seconds. Okay. Jashin. X squared minus 9 was x plus 3x minus 3, right? Right. What's the square root of x plus 7 squared? It's x plus 7 minus 3. And then x plus 7 plus 3. X plus 7 minus 3 is x plus 4. And x plus 7 plus 3 is x plus 10. Now, if you were in my class in the 10th grade, I gave you a real handy trick to dealing with this. Does anybody remember what it is? Hurtful.
I don't even remember doing this stuff.
Hurtful. None of you? What?
That was like 4 semesters ago. Yeah, come on.
X plus 7 squared minus 9. What there makes this bothersome? The x plus 7, right? X plus 7 equals a. What can I write there? A squared minus 9, which is a plus 3, a minus 3. What is a? X plus 7. Everyone remember that now? Huh? Okay. I agree with you, Sarah. It is more steps for this question. So, let's write this question. All right. Is everybody good to there? Almost everybody can factor that way just fine. Then we get to the one that everybody has trouble with.
What's x plus equals? No, it's the
What in number 4 bothers us? The 3. We have one tool to get rid of the 3. We divide by 3. Can I do it here? No, I cannot. Now listen to me and listen to me carefully. All of you, 90% of you were in my grade 10 class. You know how I am going to show you how to do this. A couple of you weren't, and there's a couple of people from another country here. There are lots of ways to factor this type of trinomial. There's the way I learned when I was your age. There's the way that is taught now to most people, which I find to be very confusing because you have to guess and remember where to write certain numbers. Then you're writing X's and pluses and all this crazy stuff. And then there's a third way, which always works. You just have to remember one little thing. I will show you all 3 of them. You will choose the one you want. Hopefully you will choose the one I like the best because it's far and away the easiest one to use in my mind. Let us begin with what I was taught when I was your age. We don't like this 3, right? If that 3 wasn't there, we would know how to factor this, correct? But that 3 is there. If that 3 wasn't there, I would need factors of 7 that add to 10, yes? Right? But that 3 is there. So x is now 3 times bigger. Agreed? So now I don't need factors of 1 and 7. I need factors of 3 times bigger, yes? So I need numbers that multiply to 21. How do you find 21? You take the first term, which I'm going to label A, B, and C, you take the first term and you multiply it by C, the third term. And that tells you what you seek. And then you rewrite. What are the factors? You keep it as adding to 10. What are the factors of 21 that add to 10? 7 and 3. So we rewrite 3x squared plus 3x plus 10x, plus 7x plus 7. Is this the exact same as that? Yes. 3x and 7x is 10x. Everyone agrees? Then you group. Can I factor this? You group and GCF. Can I factor this?
Yes.
What's coming out of there? 3x. That leaves in there x plus 1, yes?
Yes.
What's coming out of here? 7. And that leaves in there what? Plus 1. Now you notice common factors, yes?
Yeah.
So I divide them out and I get x plus 1 and 3x plus 7. This is what we call decomposition. If you have a friend in another math class, chances are that is one of the methods they were taught to do this. I have found that to be very confusing to a lot of kids. A couple of kids like this method, so that's why I like to show it first. Because if it's the first thing I show, it's also the first thing you're going to forget. So I like to show it first. So if you like it, you will learn it. But if you don't like it, it will fall out of your head. Everybody cool? All right. That's the way I was taught. It has become not very sexy. People don't like that anymore. It's like, you know those pictures of old-timey bathing suits from like the 1920s that covered your whole body? It's like that. Nobody likes to use that anymore. But it's out there for you. Then there's this method that people have. 3x squared plus 10x plus 7. You write a little box like this. And you put, on this side, you put factors of A. And on this side, you put factors of C. What are the factors of 3? 3 and 1, right? So I could write 3 and 1. And what are the factors of 7? 7 and 1. And then you do this crisscross thing. 3 times 1 is 3, right? 1 times 7 is 7. And then you check. Do 7 and 3 make 10?
Yeah.
Yep. So then I do 3 and 1, 3x plus, sorry, I lie. You do 3x plus 7, because 3 and 7, and 1x and 1, you do x plus 1. Now, a lot of people really like this version. And it works real well for 3 and 7. Why? Because 3 and 7 only have 2 factors each. Right? If I gave you this, 9x squared plus 17x, now this version sucks. Because what could be over here? What could it be? Could be 9 and 1. What else could it be? Could be 3 and 3. What could be over here for 8? Could be 4 and 2. Could be 8 and 1. And the other problem is these can change in order. It could be 1 and 9 and 2 and 4. It could be 9 and 1 and 8 and 1. Barfy. This way is guesswork. Should we be guessing in math class? No, because there's always a way to find the real answer. Please notice over here, was there any guesswork? We knew exactly what we were doing. This is very sexy. I don't know why it's become so sexy. Everybody does this. I've had student teachers that don't know how to do this and know how to do this. I don't know why. I hate this. If you like it, use it. I know how it works. I hate it. But that's okay. I also hate Brussels sprouts. And some of you like those disgusting little cabbages. So you're allowed to eat them if you want. I won't care. You could eat them right in front of me and I would be okay with that because you're not making me eat them. Right? So if you like it, use it. I hate it. Then finally, there's the third method, which is my personal favorite. It's almost exactly like the method you already know. You still have to do A times C, which equals, in this case, 21. So we still need to multiply to 21 and add to 10. We know that it's 7 and 3, yes? So we write x plus 7 and x plus 3. Because we know it's going to be 7 and 3, right? But the only reason we know it's 7 and 3 is because we did 3 times here, correct? So we have to divide both of these by 3. And then simplify your fractions. Does that simplify? No. Does that simplify? So I've got x plus 7/3 and x plus 1. Then all we do is we take any leftover denominators and we move them to the front. 3x plus 7 and x plus 1. I like it. I think it's elegant. I think it works quickly. It is easy to do. There is no guesswork. You always have the right numbers. The only thing that's weird is a lot of students don't understand this part. That messes them up. Don't write what I'm about to do. I'm about to show you why that works. X plus 7/3, x plus 1. Foil that. That gets me x squared, yes? Plus x plus 7/3 x plus 7/3. Do we agree? 7/3 times x, 7/3 x, 7/3 times 1, 7/3, yeah? Everyone's cool with that? Now, what about this bothers you? Be honest, I know what the answer is. The fractions scare you. They make you pee your pants a little bit. That's okay. How do I get rid of 3? I multiply by 3, right? Multiply this whole thing by 3, and I get 3x squared plus 3x plus 7x plus 7. Yes? Yes? Okay. 3x plus 7x is what? (10x) plus 7. And you can see I have the same number. That's why this works. The only reason we move the 3 to the front is because we don't like a fraction there. Jorrit. Yep. And any leftover denominators, just move to the front. Cool? Choose your weapon. I don't care which of the 3 you use. My brain works for all of them. Is everybody good? All of that is review. Page 53 is your 53, 54, 50, up to and including 55 to 55 is due Wednesday. Wednesday. because tomorrow you have a test. I give you maybe I'll just come around and check it. That's your risk, Sarah, not mine. Everybody good? Go.